So welcome to this video. In this video, I am going to give you explanation about Young's modulus calculation by making use of single cantilever. So in this picture, you can look at a single cantilever which is fixed at one end and the other end is free. Where here we are going to apply load in steps of 50 grams. So the load now applied is 0. So consider this as 0 load, and we are going to increase load in steps of 50 grams up to 250 grams. And here is a pin. So here we are going to focus the tip of the pin by making use of this traveling microscope. So in the field of view, you are going to get the inverted image of the pin. By focusing the pin at crosswire, you have to record the reading by making use of this equipment. So here this is a digital traveling microscope. Okay, so here it is already focused to the crosswire. Now the reading is showing as 9.49 mm. So that's what the first reading. And now I am going to apply the 50 grams here. Okay. So once we apply load, the cantilever bends. Once it bends, since we are getting inverted image, the pin comes down. By operating this screw, we can able to refocus the pin to the same position what we made earlier. So just I am going to refocus it. Slowly you have to refocus it until it is focused to the position. So for that, it is observed that the reading is 8. It is observed to be, now it is decreasing. It is decreasing slowly. So for 8.17, it is focused to the crosswire. So that's what. So you cannot see that in the picture. So it is focused to the crosswire for 8.17. And then increase load in steps of 50 grams again. And the corresponding reading has to be recorded. So you have to continue the experiment till you reach 250 grams in the scale pan, and for each load you have to record the digital traveling microscope reading. So I am going to show you the readings whatever we got by conducting this experiment. So these were all the set of readings recorded after conducting the experiment. So for 0 load, it is observed that 9.49 millimeter, and for 50 it is 8.17, for 100 it is 6.75, for 150 it is 5.46, and for 200 it is 3.99, and for 250 it is found to be 2.49. So these were all the set of readings obtained. So here as we increase the load, the value, that is the scale bends, and hence the readings were all decreases from 9.49 up to 2.49. Now I am going to plot the graph. So when we plot a graph of that is load along x-axis and the depression whatever we observed along y-axis. So this is what the graph. Now I am going to plot the graph in a graph sheet and show you the slope how to find out. So this is what the graph plotted as according to the results that we obtained. So here load is taken along x-axis. So 1 centimeter is fixed as 50 grams, and along y direction 1 centimeter is fixed as 1 unit. That is what shown. So when we plot a graph, so as according to these readings, so this is what the reading taken. So for 0 it is around 9.47, and then for 50 grams it is 8.1, that is already shown, and then for 100 it is found to be 6.75, that's what, and then for 150 it is 5.46. So like this we are going to get points and join all the points, then we are going to get a straight line as shown in this graph, and take the slope. So slope is nothing but here x by m. So this is what depression x. Okay, this is the mass m. So x by m is obtained. So slope will be recorded here, and when we calculate the slope, the value will be 29 into 10 to the power of minus 3 meter per kg. So this is what the value of slope, and when we inverse this value we are going to get m by x, that is equal to 34.48. So these were all the method of calculating m by x. And then here the value of length of the cantilever is 0.205 meter, breadth is 0.026 meter, and then thickness is 0.002 meter. So these were all the data, and by making use of the formula, that is Young's modulus y is equal to 4g L cube by bd cube into m by x. So m by x is already calculated as 34.48. So include that in this formula. So include all the values here. So 4, 9.8, and L is 0.205 whole cube, and divided by breadth, that is 0.026, and thickness 0.002, so whole cube. So all the values were all in meter, and then m by x value is observed to be 34.48. On simplification, the Young's modulus of the material of the given cantilever is calculated as 55.9 into 10 to the power of 9 Pascal. So this is what the final value that we calculated out of this experiment. So, and this is the way of plotting the graph and also doing the calculation. This is the graph, and then this is what the way of doing the calculation. And finally we have to enter the reading here. It has 55.9 into 10 to the power of 9 Pascal. So this is what the value that we have to calculate. Thank you.